Okay, day 6 warm up. This is doing some sketches of graphs. So we've been practicing that lately. You guys should know sort of the steps I like to see and the work I like to see. There's actually work to show on these. So we'll go and try these 4 problems. And then, so pause it while you try these 4 and then unpause it and I will show you the answers. Okay. All right, assuming you guys tried it, you might see this negative in here and think, okay, well, that's going to mean it's going to get flipped right to left horizontally. So I'm going to give myself a little more room on both sides. So it's good to kind of maybe anticipate the size of the graph. Like, it's going to get stretched 3 vertically, moved up 1. So you're probably going to need all the way up to 4 on here, just so your graph can fit kind of within the space you're working. So that's a period, 2 pi, 360 degrees. I want radians and degrees. Cut it in half, cut it the halves in half. You get your quarters, your quadrants. To me, that's the easiest way to get a nice graph. We're going to start with the parent function, which is sine. 0, 1, 0, negative 1, 0, light dash line. And then the 2 divides the period by 2. Right, so you get 180 degrees and pi. The negative flips it over here. So this gets flipped to here, this gets flipped to here, this gets flipped to here. It's a mirror image, a reflection, right? That's what a negative inside any function does. Okay, now we're going to continue it back over here because this is where we want our final answer. Okay, I need these dots at the x-intercepts and the high points and low points, the maxes and mins. Now we're going to do the 3. So we're working from the inside out. We did sine, we did the 2, we did the negative. Now we're doing the 3. So the 3 multiplies it up to 3. And actually, I think I just did the wrong one. Okay, it's supposed to be down here because you got to keep track of which one you're doing. Now, at some point, it becomes a little easier. Like, okay, this is obviously my last step. And then the 1 moves everything up 1. So that's going to go up here. This is 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 going to go up here. And that's going to be our final graph. So we're going to make it nice and smooth. And solid. And we're going to do a little light horizontal line for the max and the min and label them. Okay, there you go. That's what we're looking at. 1 answer, 1 period. Hopefully it's 0. Okay, next one is, let's see. I don't think we're going to have that flipping left to right issue, so we can probably go ahead and put our axes over here on the more to the left side. 1 period, 2 pi, 360 degrees. Cut in half, cut the halves in half, get your quadrants. We're going to be going up to 2, but then it's going to get shifted up 1. So we probably need room for 3 when we're done. Now, cosine, parent function, starts at 1, 0, negative 1, 0, 1. So that's the parent function, light dash line. We're going to learn about a lot of other parent functions next chapter, other kinds of shapes and stuff. And that's all these. Once you get that shape down, all the other changes are the same. No matter what the shape is you're doing the same kind of stuff. 3 divides the period by 3. So just change the way the period's labeled instead of trying to fit it into the original. Your graph will be nice. Okay. Then we do the 2 or the negative 2. We'll do both of that. That multiplies all the values by negative 2, which has the effect of flipping it upside down and also stretching it vertically. Okay. And then now we got to do the absolute value. Okay, so we got to do order of operations, PEMDAS. So now we're to the absolute value before the plus 1. Absolute value flips the negative parts up. So this goes up here, and this goes up here, and this is your new graph. Okay, and plus 1 moves everything up 1. So remove all those dots. I want to see these dots in your final graph, and as you're going, you should be keeping track of them. So this is the final graph, but I only want one period. This is clearly now 2 periods worth of this shape. It was 1 period before we got to the absolute value, but this is all I want. So I'll go ahead and you could just darken in that one, and I'll be like, that's good enough. You know what I mean? But now we should maybe put the period right here as pi over 3 and 60 degrees. And we're going to label the max and the min. So this is up at 3. The min is at 1. There you go. That's the graph. Okay, next one. Again, I don't think we're going to be reflecting horizontally, so I think we can safely give ourselves lots of room to work over here. 2 pi, 360 degrees, cut in half, cut the halves in half, get your quadrants, your quarters. Now, I don't know how much we're going to multiply by 2, move it down 1, take the absolute value, add 1. I don't know how many values we're going to, how vertically big it's going to be, but we'll just be conservative right now. So we need to graph the sine curve parent graph, 0, 1, 0, negative 1, 0, y dash line. Okay. This is going to be a crazy graph. There's no way you could predict what it's going to look like, I don't think, without having taken, any steps of work. The 4 divides the period by 4. Okay. The 2 multiplies everything by 2. So it makes it taller, stretches it. Okay, working from the inside out, order of operations. Then we're going to do the minus 1, which moves everything down 1. So this gets moved down 1, that gets moved down 1, this one gets moved down 1, this gets moved down 1. Down here at negative 3, this gets moved down 1. So light dash line. Okay, now we're going to do the absolute value. The absolute value makes everything that's positive stays positive. So this part stays like this. I'm not going to darken it. I'm just sort of making it try and stand out a little more. But the negative ones get flipped up here. And that's the first thing I do is I'd flip the dots up. It's way easier to connect these dots. So this is going to go all the way up to 3 now. And this negative 1 is going to go up to positive 1. Now this part of the graph kind of just looks like a regular curve. And then it should, what would happen is it would start to curve this way, right? And this way. And so you get these sharp corners right here. Okay. It shouldn't look like, it shouldn't look like this. Okay. It looks like this. So these parts are concave up. Okay. Just because that's how that graph gets folded. That's how we get these, sharp corners. Now, the last step is to move everything up 1. So this moves up 1. This moves up 1. This moves up 1. This moves up 1 to 4 now. Trying to just keep track of that. This moves up 1. So your final answer is, and this graph, I think it follows that curve. And then, like I said, these should look like, this should look like it's following the natural progression of that curve until it hits that point where the absolute value flipped it, right? So that's your final answer. This is your max. This is your min. Now this only goes down to right here. It doesn't go all the way down to here because this is where it starts again. And that is 1 period worth, okay, of the function. So that's what I'm looking for. Next one. So label the axes. Arrows on the ends. Let's make these look good. 1 period worth, 2 pi, 360 degrees. Cut in half, cut the halves in half. Amplitude. Sine curve starts at 0, 1, 0, negative 1, 0. Okay. Now, there's a 2 in here that's going to divide the period by 2, for sure. But the thing you got to watch out for is people are going to think this is a horizontal shift. And it's actually kind of, when we have something subtracted afterwards, that's a vertical shift and it's down, which kind of makes sense with negative. But with horizontal shifts, they're actually, it kind of has the opposite effect. So the fact that it's negative actually means it's a positive shift. But people think it's going to be pi. You actually need to take the 2 out of everything. Anything that's in front of the x needs to be factored out, anything. And the shift is actually pi over 2. Okay? Now, this is pi now, so this is pi over 2. So it moves the whole graph over another pi over 2 to 3 pi over 2, right? So this goes to here, 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 and this is the new graph. It just moves it all to the right, essentially half of its period. Now, I would like the original graph, hopefully, to start right here if possible. So we're going to bring this new graph back, kind of like we've done with the reflections, and just focus on this one. And this is actually it. This is the final answer. So this is it. Okay. This is the max. This is the min. And that's your answer. So hopefully you're getting the hang of these graphs. This is going to pay off big next unit when we study all the other kind of shapes that you've learned over the years, because we're going to make sure you're really good at all these basic graphs. Right now we're getting really good at trig graphs. But all these changes that happen to the original graph called the parent function are the same things that happen to these other graphs, the shifts and the stretches and the reflections. So if you get good at them now and get good at this process I'm trying to encourage you to do, these other ones will be a lot easier next unit. So there you go. We'll be doing the lesson next.